Great. So I think we can get started with this session. Once again, good morning, everyone. Glad to have you this morning. We're going to get started pretty quickly. My name is Edric, and I'm the marketing coordinator here at Fuse Forward. And I'd like to welcome you to episode 11 of our webinar series, Remote Control. I'm really looking forward to today's topic. We are taking a look at how we can maximize the productivity of your mobile workforce using real-time analytics. Presenting today, we have Lorenzo Cazzoli, CFO of Decision Brain, and Mark Dam, who is a regular on this series. And without further ado, I think that's it from my end. So I'm looking forward to this session, and I'm not going to waste any more time. So I'm going to hand it over to you, Lorenzo.
Good morning, everybody. My name is Lorenzo. I work for Decision Brain. We are a software company specializing in mathematical optimization, prescriptive analytics solutions. So I'll be presenting one of the solutions we implemented for a major mobile maintenance field service company in the UK with a field force of about 2,000 employees all around the UK. I have a few introductory slides to go over some of the trends, some of the characteristics that we see in terms of innovation, technological innovation related to utilities, mobile maintenance, and field service industries. And then I will dedicate a few minutes, 10, 15 minutes to showcase and do a demo of the solution. What we see is that the utility industry has in recent years embraced some of the technological advance in advanced analytics to be able to improve their own operations. And in climate change, as an example, is one of those external disruptive factors that have a tremendous impact on daily operations for utilities and mobile maintenance companies. As a recent example in 2020, but we have such examples not just in the US or North America, but all across the globe. And every year, the power outages in Texas due to extreme climate conditions were so extreme that anything that was planned during that period for the mobile workforce had to be redesigned real time on the spot to be able to cope with all those adverse events that were popping up every day. So digital innovation has become a mainstream in the discussion of CIOs of utilities, field service companies. And referring back to a study that was published by IBM a few years back, already 3-4 years ago, innovative utilities actually were those that embraced technology, were those that delivered a compound annual growth rate significantly above their peers when we're looking at their overall return on investment from a shareholder perspective. When we look at the overall when we look at the IT systems structure from a utility or a field service management company, and here I'm leveraging a framework presented by Gartner. There are different pieces of software that interact one with the other, that deliver different functionalities. So you have the functionality of managing assets, employees, records, SLA, which is what is called operations. Then you have another piece of software that is about analytics, performance metrics, integration, service bus, and so on. A piece that is about managing the demand that is mainly delivered through help desks, appointment systems, and so on. A functionality about planning the workload for the mobile workforce. And then more and more, I would say nowadays, all the utilities have mobile, or the vast majority of them, both utilities, field service companies, but also other companies that have mobile workforce. I'm seeing, for example, in the pharmaceutical sector, for the pharmaceutical salespeople, they more and more have mobile devices to be able to capture and react to real-time events on the field. And then you have all the functionality about, I would say more the paperwork the billing, and the financials. We at Decision Brain, we work in these aspects, the planning aspect of the workforce. That means our solutions are, they are like an added intelligence on top of the overall system architecture, and through a mathematical modeling approach in the field of operational research, we basically help companies define their optimal plans to be able to cope with the workload that they have to deliver in the coming days. So basically what our system does defines the optimal scheduling of tasks for each one of the mobile worker technician in order to maximize the productivity, minimizing travel time and idle time. So the work we do is in what is called typically prescriptive analytics. That is the work of data science that is about supporting decision making. Just to give you an example of why it's important to rely on a mathematical approach for this type of decision. If you take, for example, the complexity of scheduling mobile workers to serve different customers in different locations. If you take one mobile worker and 5 customers, you have 120 possible routes. If you take the same mobile workers, but double the number of customers, you have 10 customers, the possibility of routes goes up to 3 million. And if you have 100 mobile workers and 1,000 customers, then you have more routes than sun grains on Earth. We're in the orders of billions and trillions. So prescriptive analytics is useful in case where you have a vast amount of combination possible, and you want to make sure that you're choosing a combination that minimizes or maximizes a given objective function that could be productivity or SLA adherence. And this is done how? This is done, first of all, by defining what the input variables and parameters are. In your case, it could be the demand for services, your capacity, the list of your employees, the different skills that they have. Defining what the output variable should be. In the specific case of the solution that we showcase is the specific schedules for each employee for the coming day. That means who has to do what, in what sequence, in what location. And you're working under certain constraints. That could be certain location has specific opening hours, other location needs certifications to be accessed, and so on. We basically take all these variables and constraints, convert them into data structures that then feed into mathematical models. And these mathematical models crunch the data, and at the end, they give us a result. One, the combination that basically, that combination of output variable that basically minimizes or maximizes one or more objectives that in this specific case may be maximizing the productivity of your workforce, the number of tasks that each engineer performs per day. And this is done by optimizing the routes, minimizing the traveling time and the idle time, ensuring that you're always sending the technician with the right skill to the right place, for example. You might want also to maximize SLA adherence. You might have deadlines to perform specific tasks. So these mathematical model takes all these into considerations, and they give you optimal solution that ensures that a given objective function is either minimized or maximized. Then when we're talking about planning, it's always important to keep in mind that there are different planning horizons. And from our experience in working in field service utilities, but also in other types of workforce intensive sectors, it's always important to be able to achieve the maximum level of productivity, the maximum level of optimization, to integrate the different planning horizon. You typically have a strategic horizon when you're looking beyond 1 year. And in here, you're defining how many people you need, where your technicians should be located, what type of skills they should have, in what type of shifts they should work, what part of the workload should be subcontracted and what should be performed in-house. So this is more of the strategic design. These are decisions that you don't take on a day-to-day basis, but you typically take once per year, looking at the next 2 or 3 years. Then there is a tactical design, a tactical planning design that in the case of mobile maintenance, utilities, and field services, about how do you optimally distribute your recurrent tasks, so your planned maintenance. Imagine you have a planned maintenance that has to happen twice per year. Shall you do it in January and July, or you do it in February and August? And then there is, of course, a third level, which is the ones that probably you're most familiar with, which is the operational level. That means you need to schedule the jobs for your technicians for the next 1 or 2 days. And that's where a lot of companies focus, mainly on the operational scheduling. But what we found that there are optimization opportunities along the other dimension, the strategic and the tactical as well. And you get the maximum optimization out of the system when these different horizons interact one with the other. When, for example, you define your tactical plan for your employees' vacation or for your planned maintenance tasks, and these you use it as an input to your operational scheduling. And the changes you need to do at an operational level then feed back into the tactical planning to adjust the plan for the coming months. Now, when we look at the case specific that I'm going to show you, we're in the domain of operational scheduling. So the next 1 day, 1, 2 days, 3 days. And here planners, basically they need to ensure that the field force, your mobile workforce is productive. So they perform as many jobs as possible. And at the same time, they have to manage customer requests. And in your field, there is a lot of what's called reactive tasks, so unexpected events. So what we've seen in this customer when we got in is that these planners were like firefighters. So they were the whole day on the phone trying to talk to the different technicians, changing their plans and reacting to unexpected emergencies that were coming up every day. So our system is a decision support system, and what it does in their case is it helps them take the best decision in terms of how to best dispatch the jobs to the employees, what priorities the planner should really focus on, what are the emergencies really that he should focus on, and leave the rest for later, how to better manage real-time unexpected events. You might have, for example, a job that was planned for 2 hours, and it's actually when the engineer gets there, it's going to take 4 hours. So everything you planned after that, you better replan it because it's at risk. It's not going to happen. You might have, on the other hand, opportunities. So you might have engineers that finish early a job that was planned for 1 hour. It takes them just 20 minutes once they get in the location. So this is what we define opportunities. And our system really helps the planner manage these different events, gives them suggestions, and proposes to them the optimal way to adapt the plan to these unexpected real-time events. So at the end, it's about a real-time response. You can plan, and the way our system works is at night, it performs a global optimizations for the next day with all the available tasks for all the available employees for the next days. But during the day, it allows the planner to react and to adjust the plan in real time. It allows the planner to focus on priorities. There are so many things that happen during the day that it's important that really focuses on the priority. It ensures employees' efficiency and productivity. And at the end, what it leads is to a cost leadership and the service excellence in the sense that when you have a productive workforce, when you're respecting your SLAs, that's where really you're managing to reduce your cost and bring up your competitiveness. In terms of how the solution works, our solution is web-based. It integrates real-time with other systems. In the case of the implementation we did, it's integrating real-time with Maximo, IBM Maximo. And everything that goes through the solution that I will show you is a solution for the planner, and every decision taken on the solution is then sent real time into the mobile application to the technician, and the technician can also interact back with the solution by saying, for example, yes, the job has started, but it's going to last more than what it was planned, so that the planner can react to these unexpected events during the day. So this is all I had in terms of slides and presentation. Let me then move, if I can, quickly into the solution. Edric, you see now the screen?
Yep, I can see the screen.
Sorry. Yes, so this is, let me make it a bit smaller. So this is how, yeah.
Looks great, looks great.
It's okay? Can you see fine? Oh, okay. So this is how the solution we developed for this mobile maintenance company in the UK that has about 2,000 employees, how it looks and feels, and the different functionality it has. One thing I need to say is that we are a company that always like to customize our solutions to the need of each customer. So what you see in here is what, of course, the customer wanted specifically, but for us to customize, for example, this dashboard that you see here with different KPIs, customize it to different types of KPIs, different color schemes, different types of wording would be very easy. The platform we use allows to easily customize our solution to the specific need of each customer. So let me do just an introduction about the functionality of this tool. Again, this is a tool that works real time. That means it interacts real time both with Maximo and with the mobile application. In the case of JLL, I think it's Cognito. With the mobile application on the field. So what you see here is an interaction with the rest of the system infrastructure of the customer. From a functional perspective, you always have a dashboard. The dashboard is designed to allow the planner to focus on the important things. So here you have jobs in jeopardy, which are those jobs that you might not be able to perform because, for example, the technician is late, or the task that was planned to take 2 hours is taking longer. So all the subsequent jobs might be in jeopardy. You have another KPI that highlights those jobs are due today and are not assigned. You might ask, why does this happen? Well, as I was explaining before, every night the solution runs what is called a batch optimization. It takes the whole set of tasks that you have, the whole set of employees, and optimally distributes them, creates the optimal schedule for each engineer or technician, so that when the planner comes in the morning and when the engineers turn on their mobile every day, they have the whole schedule for the day. But new jobs might have happened, for example, during the night or early in the morning. So there might be some jobs that are urgent jobs, typically reactive maintenance, that needs to be done because of the SLA today. And they will pop up here as an assigned jobs that are actually due today. You have absences, that is technicians that haven't showed up, for example, and how many jobs might be impacted for that. You have opportunities. I was telling you before, these are, and we can even click on it and it will give you a summary of the employees ranked by how many available hours they have. So you have employee number 8 that still has 3.7 hours for the day. This is an opportunity, and 3.1 hours. So everything above 3 hours, I guess, I think it's considered an opportunity, so that the planner can actually assign more jobs to this employee. And then you have some other KPIs that more about the quality of the plan. Here says average jobs per technician, for average travel distance per technicians, and so on. So, and then you have a visual representation of some of these KPIs. One important thing to highlight, I don't know if you saw the message in the last slide when before starting this demo. Uh, in this implementation, the customer was able, in some cases, even to double the productivity. I would say that a 30 to 40% increase in productivity is, I think, more feasible and more aligned. But there were some specific cases in some regions where the increase in the number of average jobs per day done by each technician was actually even higher than that 30 and 40%. This is specifically thanks to two factors. One is reducing the travel time and distance by optimizing the routing, and two, ensuring that you're sending the engineer with the right skill to do the job, which was not always the case before. Then you have other views. Let me show you here the plan view. The plan view gives a snapshot, and of course, I'm showing the case of one planner. If I logged in as a set of a different planner, I will have a different set of engineers. Here, typically, each planner manages 30 engineers, 30 or 40 engineers. In here, you have all the engineers, all their daily Gantt chart with the schedules. If it's gray, it's because it's not working today, this engineer. So you see the shift, you see the different tasks that have been assigned to them. And when you select an engineer on the right, you will see the route, the specific route that the engineer has to do during the day. In the real system, you will also see this is a demo, but in the real system, you'll also see where the engineer is based on his location, on the GPS of his mobile device. There is a color coding that helps the planner also to quickly spot potential issues or opportunities. So everything that is in red is a job that is due today. So it has a deadline for today. If it's in orange, the deadline is for the next 3 days. If it's in green, is because the deadline is after that. And if it's black, it's an appointment or a statutory job. So appointment is when you fix a specific day, a time of the day and a specific day to perform a job. And you cannot move that. So these are in black are the appointments. The light color in here, I think for the sake of demo, you see here in light color, that means the job has already started. So the engineers on the field said, yes, I got to the customer and I started the job. And you can already see from here that probably the engineers that has the issues of jobs at risk is this one, because you see there is a job that started, but now it's overlapping with two appointments that had been planned. And it's because this job, the engineer, the feedback of the engineer to the planner through the system was that it was going to take longer than what was actually scheduled. I will show you then how to handle the situation of jobs at risk. Then you have a view, which is a summary of all the available jobs. By default, these are filtered by unassigned jobs. You can click on a job. You see a job has the type, which is reactive maintenance, the craft or skill, which is an air conditioning one, the number of the work order, and a lot of information, the due date, the location. When you click on a job, it opens a side panel. The side panel gives a bit more information. It tells you where the job is. And then you also have a link to a new view that allows you to assign this job. So here is a view that the planner enters. Automatically in this view, the system will show all the technicians that have the skill required for this unplanned job. The unplanned job that you want to plan is this one in blue. And the system shows the schedules of the employees with the exact skill required for these jobs. So in this case, all these engineers have the air conditioning skill. But if the planner wants, he can also decide to look at all the engineers, not just a compatible one. And the system will show all of them. In red are the ones that actually don't have the skill that is required by that specific job. Then the engineers, as you see, are ordered by distance from the job. So the first one is engineer 18, that is 4 miles away, 9 miles, 11 miles. And what the planner can do, he can move, drag and drop. Here, there is no space in this first engineer. What he could do, he could unassign some of the jobs, but let's try to put it on this engineer here that is 12 miles away. And then let's ask the system to recompute the travel time. And the job has been assigned then to this engineer. What then the planner can do is he can undo, if he wants, this change. He can save, or you can even ask the system to run a local optimization. So what the system does in here says, tries to find the best changes to the plan in order to fit these unplanned job to any of the available engineers. So the system will run a local optimization and will give a suggestion to the planner that the planner can accept or not accept this change. And once it's done, he saves the changes. The system say, hey, be careful because the job might overtime, or there might be some other constraints that are broken. The planner always has a possibility to override this. And now the job is published, is sent to that engineer in real time to his mobile application so that he sees that that's a new job that he has to perform at the end of the day. You have a similar view, which is the engineer's view, that is similar to the jobs view, but takes the perspective of the engineer. So here you have the list of all the engineers, how much their utilization is during the day. So you can see those that have more available time to be able to perform more tasks, and how much travel distance they run. You can choose an engineer. Again, a side panel will open showing where the engineer is, what is his route for the day. And here again, you can try to assign more jobs to this engineer. Different from the previous view, here you have a list of jobs. These are the ones that are already assigned to engineers. You have other jobs that are ordered in terms of distance, and are those jobs that the engineer has the skill required to perform them. So in here, the planner again can drag and drop. You see now the Gantt chart is here on the right with the daily plan of the engineer. And the planner can just drag and drop it here, ask for the system to recalculate. The system will give probably some warning that you see here. Also, there are a bit of a warning. It says the job will be performed in overtime. So again, the system, the planner can undo, can ask the system to find the best assignment. So is there any job that hasn't been assigned that can be assigned to improve the schedule? We will run a local optimization to try to find the best match to try to improve the productivity of this engineer. So another characteristic of the tool is every time, this is a tool that is shared across different planners. So every time a planner makes a change in the schedule, the system will publish a notification that is available for all the planners to look at and see, you know, here we changed the plan job. There are some jobs in jeopardy. These notifications come in, for example, real time, if there are some updates from the technicians saying that they are late or so on. Then if you go back to the dashboard, you remember there were 2 unassigned jobs. We assigned one before, so now the unassigned job due today is only 1. But there are still 4 jobs in jeopardy, which let's take a look at them. Are related to that technician. If you recall that I singled out the beginning is technician number 9. And you see here the reason is that is ongoing an activity that is taking longer than what expected. There is an appointment in the middle. This appointment will probably have to be unassigned and replanned for the next day. So the planner can unassign it, ask the system to recompute again the schedule and the new travel time, and then go ahead and save the changes. Of course, the system will warn there's been quite some changes. He saves it. And when we go back to the dashboard, there are no more jobs in jeopardy. So in this case, the planner was able to react to this delay. Now you see they're back to unassigned jobs today because that appointment that I took out from this engineer was probably due today. So now the system points out that that is overdue. Okay. There is just as a last feature here, Edric, before passing it back to you, I just want to say that in each of the views here, you can go into the jobs, to the plan. You see there is a set of high-level plan KPIs, average number of jobs per engineer, average distance that is run by each engineer. They stay always here so that when the planner make any change, you can see the impact it has on these planning KPIs. It doesn't need to go back to the dashboard. So that would be it. These just let me high level say that this solution has been implemented, as I said, in a UK mobile maintenance field service company. It's the biggest player there with about 1,800 to 2,000 technicians covering the whole country. It is a complex integration that FuseForward was involved and developed and deployed, and it's a real-time integration with different systems, the mobile application, the HR system, Maximo, and so on. And the result, the customer was quite satisfied in terms of the improvements in productivity that this solution actually provided to them. So, Edric, I would open it to questions, send it back to you.
Yeah, we actually have one question here. He says, do you have a weekly/monthly display for the jobs that last more than a day?
Okay, so this is linked to what I was saying before about the different planning horizon. This tool here that I'm showing you is an operational tool and has a capability, in this case it's 2 days, but has a capability to go up to 2 weeks. Then we have another tool that can integrate with this one that actually does a tactical planning that goes from 1 month all the way to 1 year. And this is the planning horizon in which you want to distribute your frequent task. That means mainly the plan maintenance that might have a monthly, a quarterly, twice per year or yearly frequency. And this tool finds the best week of the year in which you should perform these plan tasks. And it's also the planning horizon in which you should program the holidays and vacation of your technicians, because the idea of the tactical planning is that of smoothing out the differences between the volatility or seasonality of your demand and seasonality and volatility of your capacity. Okay.
Great.
So, but this tool here that I showed, it goes up to 2 weeks, 10 days. We had instances in which it was implemented this way. We could extend it up to 30 days to then merge it with the tactical one, but we haven't had the necessity to do that so far. In this specific case, you see here is a 2 days. So when you choose the second day, you will see the plan for next day. Don't look too much at the detail. This is a demo environment with some sanitized data. But again, in this drop down, you could go up to the next 2 weeks.
Awesome, awesome. We have another question here. The dashboard has a lot of interesting data. Was it challenging bringing this data together?
We rely, let me ask a question. Is it challenges for us to develop the backend to then compute the KPIs, or challenging to get good quality data from the customer? because if the question is the first, it's not difficult for us. We rely on a platform to develop these solutions. So this platform has data management and scenario management capabilities. So it's not that difficult for us to come up with different types of KPIs. And that goes back to what I was saying, that it's easy to us to customize it to the necessities of different customers. But about data, actually, the biggest challenge is to ensure that the quality and availability of the data coming from the customer is actually good. And the implementation of this tool, I can give you the example of these customers in which we implemented it. It needed, after it was implemented, they realized the quality of their data was not as good as expected, especially in terms of opening hours of the locations. So the engineer was getting there because the system thought the location was open, actually was closed, and in Maximo it was not correctly reflected. And another big issue was the mapping of the skills and the duration of the planned task. So these typically are the three type of data that where we encounter some issues of not really availability, because most of the companies have them, but quality. Are they exact? Are they precise, or more or less precise? Because of course, if you tell the system that a planned task takes 60 minutes, he will consider this as 60 minutes. You can build some variability around it, but if then it takes 3 hours, there's not much the system can do. The engineer will get there, and he will have some jobs in jeopardy because it's going to take much longer than what the system thought. So yeah, data availability and data quality is typically an issue. That depends on the maturity of the data and the system structure of the customer. We do work a lot with the customer to help them in this case, because once you implement this system, also these data issues that before were not that evident, they become clear and evident.
Awesome. We're getting more questions here, but I think I'm going to reserve that for the end of the Q&A. I just want to say thanks, Lorenzo, for showing us the demo. And yeah, so we have a demo request for everyone to see if you want to have a personal demo for your organization. So I'm just going to put a poll up here. Do you want to request a personal dynamic schedule demo, the one that you just saw? If yes, just indicate. For those people who've selected yes, we will email you, and we'll get in touch with you to see if that is a possibility. Thanks everyone for answering the poll, and yeah, we'll move on to the presentation. We want to highlight, I guess, our relationship with Decision Brain, and we brought our Peace Forward CTO Mark Dam here to showcase that. So I'll leave it to you, Mark.
Yeah, I wanted to first off thank Lorenzo for sharing the presentation. We've worked with Decision Brain for about 5+ years already on a number of projects. One of the key things that we do want to share is Lorenzo was sharing a fair bit about how do you integrate all these systems together. Well, that's kind of where we come to play. Part of what this is in a lot of the projects that we've worked together on, they basically have been building out the analytics, certain analytics optimization services. And somebody needs to run all those applications. And not only that, but how do we get data in? So I think Lorenzo shared a little bit about some of the areas of how do you calculate the key performance indicators? How do we get the data in? So one of the areas in one of the accounts we work on, as an example, we've had to go through and ingest streaming data sets coming in from movements out in the field. And how do we do that? Well, we do that through our platform technology. We stream in the data, and in some cases calculate some of the key performance indicators or normalize the data sets so that the Decision Brain team has access to the data in real time coming in from all the metering points out in the field. Correspondingly, the other areas that usually come in is how do you go through and take the data that's coming from the Decision Brain environment and their decision support tools, and how do we push it back into the Maximos or the field operations? Again, we need an integration engine, and part of that integration service comes into some of our platform and some of the technology that we run in our cloud platform for these customers jointly together. Now, what I do want to share, if you want to move on to the next slide for a minute. So what's the role that we usually play? So we have a number of partners. Decision Brain's been very good with us in working together. One of the projects, in fact, in most of them, we're usually there at the beginning stages of it and looking with the customers and say, well, how are we going to go through and integrate this app in? How are we going to run it in the cloud? And how are we going to scale it up and scale it down at different times of the day based upon load profiles? So a lot of that has to do with the architecture of how the system is actually architected to be deployed. So we work at that stage of understanding how it's being put together, things that we can do and look at using tools like the AWS, certain AWS services to help that come together. And we're there at the very beginning to say, okay, let's start planning for midnight runs. And how are we going to go through and ensure that there's enough compute capacity in the middle of the night to run all the optimization jobs? Then how do we make sure that the appropriate service performance is available during the day in order to go through and run it during the day? So that all comes in, not just because of the architecture, but all the deployment models and everything that we drive in order to do that. Now, once the system is running, well, who goes through and runs it? So we have different areas, and our job as the cloud service provider is we actually run all of the applications for the clients. So as Decision Brain builds a new version or they do enhancements to their product, our team takes all of those code packages, we bundle them all up using automation, and we deploy them and control the deployment into the production environments for the customer. So that's all part of that whole deployment model and making sure that the system is available 7/24, 365 for the customers, and that they're running in a secure private environment for them. So when we're talking about security and in a private environment, how do we do that? Well, part of the other parts that we do is we are also acting as the first line of call for any sort of performance of the system, and we're monitoring all of the points to make sure that it's operating efficiently. We do all the troubleshooting. If there's certain jobs, we collaborate very tightly with the application managers who are responsible for making sure that there is a bug in the software or there's something going on where the system's not being used right, that they can educate the end users. But then they're always looking for support from team members that are going to be there in deep with how the actual application is running inside the client's production environment. So for us, we provide a fully managed service, and we jointly manage and work on those jobs with these independent software vendors like Decision Brain. And this one is, we have a number of accounts as an example, multi-year agreements and multi-year contracts where our teams are highly integrated in handling service tickets, handling deployments of the code packages, and continuing to evolve and elevate these products into new customers as we are looking at going forward. So I think the partnership is real. It's a very good one. I do appreciate Lorenzo spending the time and sharing some of the visualizations and a great demo. Always love seeing that product. I know the clients are very happy with both your services and ours and helping them to efficiently manage their field crews out in the field. Now, on that note, I do want to turn it over a little bit and finish off a little bit of the Q&A. It sounds like there's a few more questions, and Edric, if you want to go through and share some of those, Lorenzo can always go through and answer some of the questions if there's any more for ourselves or anything for Decision Brain to wrap this up. And we got about 2 or 3 minutes left.
Yeah. So we have a couple of questions here for, I think, directly mainly at Lorenzo. He's asking one more question. Since the representation of jobs seems very precise and real time, are you integrating to timesheet reporting on the engineer level? Not sure if Lorenzo can hear me. Lorenzo, are you there?
Yeah, well, as Mark said, in terms of integration, the system can be integrated with any system in the architecture of the customer. In this specific case, I don't know. Do you remember, Mark, if this was done in JLL, this integration?
Yeah, so the timesheets, are we integrating very precisely with timesheets at this point? So not in their way of their actual available, like what happens is the engineer out in the field does fill out timesheets on their mobile device. Mm-hmm. That all gets published back in real time with the time that they're spending on the job as they're doing that. And it does go back into the work order management system, which in this case is IBM Maximo. And then what happens here is if there is that, if you noticed on the screens that Lorenzo was showing, where you were seeing the availability of the field workers, those are actually coming back because there is a real-time integration between that field worker entering time and their availability out in the field from their mobile handheld device.
Great. We have another question here. Can we collect data in order to use it in a learning process to estimate the best assignment model?
Yeah, I'm not sure if we understand the question, but is it if we can have data and run it through the system? Because the system, what it does, it has embedded an assignment model based on an objective function of minimizing travel time and maximize SLA adherence. So would it be to try different types of assignment model?
He didn't really specify.
Oh, I mean, hey,
Yeah.
Lorenzo, one of the things I can talk about is we can go and look at one of the other accounts that we have. And one of the things, if you look at some of the areas that you're talking about in the way of a learning process, you could be referring to machine learning. And if we look at some of the dispatching workloads, there is areas where Decision Brain has used some of the ML capabilities in other optimization data sets. So there's two areas. One is the area where Decision Brain is building an optimization service, which is more geared towards not using ML, but more of an optimization problem and a best route possible. And then overlaying on top of that in machine learning, you actually are able to go through and do a little bit more dynamic estimation into the processes. And I do know from some of the folks that I've worked on in the Decision Brain team that's being incorporated as a second layer of optimization is using ML algorithms.
Yeah, the solution we deployed for the bike sharing in London, for example, with you guys as well, had this approach of using machine learning to be able to estimate the forecasting the reactive type of events that could happen with a granularity of 10 minutes. And then the optimization we're using this as an input to be able to define what the optimal reassignment would be based on that forecasted demand. So yes, sometimes in some of our solutions, not in this one that I showcased, but in others, we complement the optimization with the machine learning techniques to be able to predict in the short term workload, typically by type of skill.
And I think that kind of talks a little bit about one of those last questions there, Edric. I'm just going to jump in on that last one.
No, yeah, go ahead.
I think we kind of answered it, and
Yeah.
it is, do you use AI use cases and requests for things like dispatching, skill set learning, and load management? So if you look at this one as a simple one, which is more of, I don't want to say simple because Lorenzo kind of did point out the number of optimization problems there. But if you start thinking about the more complexity you start getting into, especially in, say, utility accounts, where it's not just the load time, the travel time optimization, but it's also outage management and dispatching, where you have to do safety protocols related to breakers or being able to do controlled shutdowns of transformer stations. That adds a much higher level of complexity. And that's where we do see, as an example, another layer of machine learning being able to go in to look at a more complicated optimization problem. And not just the optimization, but what has people found successful in the way of controlling the actual events themselves and doing processing around events. Anything you want to add to that one? I think that kind of sounds like some very interesting questions from the field here, both around not just optimization, but machine learning as well, and the new world of AI, which are all starting to collide to change the way that we're actually working in the marketplace.
Great. Thank you very much, Lorenzo and Mark, for being in this webinar. We're going to wrap it up here. If you have any more questions, just email us or contact us on our website. And if you really like this webinar, we'll have another one in the next month or so. Subscribe to our series at peacewar.com/remote control webinar, or you can follow us on LinkedIn or Twitter, and we'll announce our next webinar very shortly. Thanks, everyone, and hope you guys have a good day.
Thank you very much.